Hello, everyone. Hello, everybody. I see there are already some people connected. Perfect. Hello, Greg, always with us. Thank you. So welcome to this webinar, the newest edition of our webinar schedule. Today, we're going to hear Jérôme Quéré, our favorite Jérôme Love. is with us, I'm sure. Jérôme is going to do his presentation, but before that, I will be doing a very short presentation about Scaleway to tell you a little bit more about who we are. Just for your information, there is a question tab on the right-hand side of your webinar screen. If you could put all your questions in the question tab, and there will also be polls that will be published throughout the webinar. So if you can keep an eye out on that and give us your answers, that will help Jérôme to precise his presentation, and us also for creating new webinars in the weeks to come. Also, quick information, this webinar is recorded, so if you want to look back on the presentation and Jérôme's slides, they will be on YouTube very soon, and we'll send you an email to notify you when you can access it. I think that's all from me for now with regards to the rules. I'm just going to do the quick presentation to give you a better idea of who we are, and then Jérôme will take over. So I'm going to share my screen. And please let me know also if you can't hear us, if there's a problem. And our colleagues in moderation, Maxime, Colline, and Melody are with us, and they will be sending you links throughout, and let them know if there's a problem with the sound or the video or anything, and we'll get to that straight away. So normally you can see my screen properly, my slides. Again, let my colleagues know if that's not the case. So quick presentation, I'm Emma Perinetti. I work as an events manager at Scaleway. Jérôme will present himself when he starts his presentation. So Scaleway, who is Scaleway? The cloud experience. So if you want more information about who we are, I'm not going to be very technical and it's going to be very brief. So feel free to open the website in another tab and have a look, scaleway.com. Who is Scaleway? We are the cloud branch of the Iliad group. So we are, for those of you who know Iliad, perfect. And for the others, you may know Free from Free Mobile and Freebox. So Free is part of Iliad, and so is Scaleway. We're the cloud branch of the Iliad group. We are a European cloud service provider, and we're pioneers, in bare metal. We are the 9th cloud provider worldwide and the 2nd public cloud provider in Europe. So that gives you a better idea of who Scaleway is on the market and what we represent internationally. To give you a few figures, we have 250 collaborators in all, so they're split between our 2 offices, one in Paris, the headquarters, and the second one in Lille, but also in our data centers, of course, the heart of our jobs and our services and products. We have 5 data centers right now, 4 of which are in Paris and surrounding area, and the 5th is in Amsterdam. This year, 2020, we're opening the 6th data center in Eastern Europe, in Poland, to be more precise. And also in terms of our clients, so we have 60% of our clients are international, are out of France, and cover more or less over 160 countries worldwide. So that again gives you an idea, of who we are in the market and who our clients are. Scaleway. Scaleway is the main umbrella brand for our 3 activities. Our umbrella brand for Scaleway Data Center, Scaleway Databox, and Scaleway Elements. Scaleway Data Center is our private infrastructure, so literally our DCs, the aircon that is needed, the electricity, the space that is needed, and all the equipment and security that goes into managing the private infrastructures. Scaleway Databox is our dedicated servers. Historically, it's also online.net, which you might already know of. And today it's named Scaleway Databox. Scaleway Elements is our public cloud ecosystem. So there'll be another slide with a bit more detail about what composes our cloud ecosystem, but it's 6 very, very different bricks that make sure that the whole ecosystem functions and grows and is able to reply to your needs and for your projects. So with these 3 activities, Scaleway Data Center, DediBox, and Elements, we have all the components necessary to bring to completion any of your projects. This is the side I was talking about, Scaleway Elements. So I was talking about the 6 bricks. So you can see them here. There's compute, storage, network, IoT for Internet of Things, the connected objects, and artificial intelligence, AI, and of course tools, which is the toolbox for the ecosystem, which gives us the tools on all the different, that enable all the bricks to work with each other properly. There's a bit more detail about what every brick is composed of. In compute, we have, our instances. It's the cloud, it's the GPUs, it's Cube and container registry. In storage, it's block storage and our C14 cold storage. Network is the load balancers, the domains, the CDN, and more. IoT, our IoT hub is currently in beta. We have artificial intelligence, and the tools, as I said, is the API, which we're going to talk about in much more detail just after this. The console, the CLI, and more. Again, there's more information on our website if you want more technical details. Just briefly to give you a quick idea of who we are, not who we are, who we reply to. Le Bon Coin, Adopte un Mec, Safran, Le Monde, Dailymotion. I'm sure they're all very familiar names to most, if not all of you. So it gives you, an idea of all the diverse sectors and industries that we can answer to, and it goes from e-commerce, health, finance, right through to the media and many other industries, of course. So thank you very much for listening to this quick presentation. Please feel free to follow us on Twitter and LinkedIn if you want more frequent updates about our new releases, our updates, our weekly tutorials, or anything else. Also, if you need to reach us, if you have questions, if you need assistance, you know where to find us on all the social media, at Scaleway and at Scaleway_FR. And once confinement is over, we will keep doing webinars, of course, but we will also go back to doing in real life events. And for that, you can follow our meetup pages in Paris and Lille, and you'll have more information about our agenda on there. So thank you very much for listening. I will now pass on the mic to Jérôme. This is why we're here. Can you hear?
Yes, I can hear you.
Perfect.
Okay, I'm going to share my screen. Can you see the presentation?
Yes, perfect. Well,
yes.
I can, and everyone in the chat can too.
Okay, perfect. So, hi everyone. My name is Jérôme Quéré. I am the engineering manager of the API Gateway and Developer Tool at Scaleway. And today I'm going to present you the odyssey of an HTTP request in Scaleway. So it's all start with chapter 1, Once Upon a Time. So for our adventure, we are going to start with a simple curl request. So in our example, we are going to take a request that creates a database using our RDB product in the Amsterdam region. So our public API is a standard REST API. So it's hosted on the single host name, which is api.scaleway.com. So it's a post request because we want to create a database. So we have the full URL with the region NLIMS that is embedded inside the URL /database to create a database. Next, we get our XAuth token, which is the authentication mechanism used at Scaleway. So every request you make to an API, you must include this secret token that you can generate in your console to be able to be authenticated with your account when you're making requests. And because this is a REST request, we have a content type of type application JSON with a body of our request that is a JSON document with the name of the database we want to create and the description of our database. So what is going to happen first when we hit enter on this request is a simple DNS resolution. So this unique host name that we want it to be unique for being more easy to use. So you don't have to worry which project or which region you are contacting. You can just call api.scaleway.com and we will take care of the rest. So this API this domain name resolved to a single IP address that is written behind and under. And so what's going to happen is that this IP address is going to be route to our API gateway. So the API gateway is a piece of software that will receive all the HTTP API requests that come to Scaleway, so they can be treated successfully. So because we want to provide high availability, we cannot have just one single API gateway. So we must at least have two. So if one goes down, we have a backup. And to do that, we use network technology configuration that's called Anycast. And what this allows us to do is put the same IP address on multiple hosts with the API gateway. So this way, the requests that comes in are automatically spread across all the different API gateways that are healthy at a given moment. And we need to do that because we cannot use, of course, other cloud provider load balancer for that. And so this is the way, and because the API gateway is a load balancer, we need to rely on network configuration and network tooling to be able to do that. So we get the same IP address on the two machines. If one goes down, then all the traffic are going to be sent to the API gateways that are still up. So what we can do with Anycast, putting the same IP address on two hosts, we can also do it across region. So this is actually the case when you are making a request to api.scaleway.com. We have the same IP address that is present both in Paris and Amsterdam. And when you are making a request, you are automatically being routed to the nearest data center. So in my case, I am in Paris. So my request is probably going to end up in a data center in Paris. And this works using like low-level network technology, old one that makes the internet works, that is called BGP. So our request arrived in Paris, because I am in Paris, so the nearest. And that brings us to chapter 2, knock knock, who's there? So we send the request to the data center. Now we are going to see who is going to be on the other end of the line and who is going to answer and receive our request. So there are a lot of well-known solutions for doing reverse proxying or HTTP proxying. Some you don't present anymore, like HAProxy and Nginx. Some that are more high-level feature-oriented, like Linkerd or Kong, that provide many different tools for doing API gateway-oriented configuration. You get other solutions like Traffic, for example, if you are that work really well in a container environment. So if you are using Docker or if you are using Kubernetes, maybe Traffic is the right fit for you. Or if you are really a crazy one, you can just start from scratch using your favorite languages and write your own reverse HTTP server. But I highly recommend you don't, because this is a really hard task to do, and there are many people that already done all the work for you. At Scaleway, after studying all these solutions, we decided to not choose any one of them, but we fell in love with Envoy. So Envoy is reverse proxy, network proxy to be exact, that was developed by Lyft, I think about three or four years ago. So it's now open source. It's part of the CNCF, the Cloud Native Foundation, like some of you may know Kubernetes. That is also part of the CNCF. And they did a really great job with this new network proxy. So we choose it for many reasons. I list the most important one here. First was HTTP2 support, because internally at Scaleway we have a lot of HTTP2 services. I'm going to go deeper into that later, but the support for HTTP2 was a hard requirement on our side. And at the time we choose Envoy, and Nginx was just about to add the official support for HTTP2. And if you are using Nginx or HAProxy for HTTP2, you can sometimes feel that the HTTP2 support was really added on top of the HTTP1 support. And it can feel, something may not feel right, because it was added later. When Nginx and HAProxy was written, the HTTP2 was not even an idea. And so Envoy being quite recent, it was built with HTTP2 supports from the ground up, and you can really feel that when you are using it. The second part is performance and security. So Envoy is written in C++, and is being contributed by major cloud actors like Google, that is actively developing on Envoy. So this is really good, and all written in C++ from the ground up, so performance are great. Another part is code-oriented configuration. So if you are running an Nginx proxy or a SHA proxy in front of 2 or 3 different API, I mean, the configuration is okay. It's human-friendly, you can easily edit it. But when we are talking about routing more than 100 services, the configuration could be really hard to maintain and to write by a human. So we use code generation, but if you want to generate code configuration for Nginx automatically, you probably have to rely on templates that is not really neat. And what Envoy does is that its configuration is code-oriented. So you can write a simple YAML file with all your configuration, but what you can also do is use their, for example, a Go SDK that's called the Go control plane, and we can use all this structure to write a strongly typed configuration. So in our case, when we are generating huge Envoy configuration, this is much more easier to do with a strongly typed system that allows us to make sure the configuration we are generating is well formatted and will work. Fourth point is mesh capabilities. So even if we are not using mesh capabilities yet at Scaleway, this is something we are thinking about, using Envoy as a mesh. And the fact that Envoy was supporting that was really a good point for us. And the last point was observability. So out of the box, Envoy exposed more than hundreds of different metrics. So you can know exactly what's going on your production at every moment. So we start from my laptop and we arrive in a data center in Paris, and the Envoy receive our request. So then bring us to chapter 3, not so fast. So the first step our request is going to face is the rate limiter. So rate limiter is really an important part for an API gateway of our size for many reasons. First, the first evident one is security. You don't want anyone to crush your API under 1,000 of useless code. So one way to secure that is using a rate limiter. But also, when you are working in a big company with many teams, with many products that are in beta or even alpha phase, you can have bugs. This happened. And in this case, it's already happened to us. A team can do a mistake and just do an infinite loop where they send you thousands and thousands of requests. And you want to be protected from that because you don't want to send all that many requests to a service and probably hurts his healthiness. So we want to rate limit also that. So both for security, external security, but also to protect ourselves from bugs and simple bugs that can happen even inside our own company. So the way rate limiter works in Envoy is that it will send information about the request. So in our case, the information we want to receive is the origin IP of the request. And the request will be sent to a microservices, so gRPC microservices. If you don't know what gRPC is, don't worry, I'm going to go into details about gRPC later. So, but it's a microservices, like an API microservices, that will receive the origin IP of the request. And in our case, we use a Redis cluster that is going to register the number of calls made by this IP on the last second, last minute, and last hour. So this free counter allows us to have a fine tuning of how many requests we want to be able to make from the same origin IP. So based on this Redis counter, the rate limited service will be able to say, no, the origin IP is over limit, so we will automatically reject the request. Or if we are not over limit, we just increment the counter by 1 and the request can continue. So then bring us to chapter 4, gRPC in action. So second crush from Scaleway is gRPC. So gRPC is a technology that is developed by Google initially. gRPC is, you can see gRPC as a drop-in replacement for REST API. So it's a tool to writing API. So some of you may know how to develop an API in REST, where you use JSON body and HTTP1 with all the HTTP verb like post, get, put, etc. gRPC is another approach of writing API. So it's based on HTTP2, and the body of the request are not JSON, but protobuf, which are strongly typed serialization message, which is also a binary type format. So why do we want to use gRPC and not REST? When you are writing 3, 4, maybe 10, or maybe 20 endpoints of your in an API, or maybe 2 or 3 APIs, REST can do a great job. But our size, we've got more than 1,000 endpoints, API endpoints, both publics and also internal. So the problem with REST is it's not growing really well because it's not strongly typed. So you always have to refer to the documentation of the team. API are writing by many different teams on Scaleway. They have many different versions of each API that can be running at the same time. So we really need to find a way to handle all this API on a strongly typed way. So we can make sure that all the messages that are sent and received are the correct one. So I'm going to show a little more example of how gRPC works and what it looks like when you use it. But strongly typed is really important. Second, it was based on HTTP2, so no weird protocol there. It's really standard, work really well with Envoy, and that's one of the reasons we chose Envoy, the support for HTTP2. And because it's based on HTTP2, it supports something REST does not, natively at least. It's the support for stream. So in REST, you are always making one request and receiving one response. With gRPC, you have native support for stream. So you can implement like pub-sub mechanism when you can subscribe to a channel and receive a lot of different responses. Or you can have a completely bidirectional stream, still with the strongly typed system. And even if today we don't expose this kind of streaming support in our public API yet, maybe it will come. We use it a lot internally, especially for when you want to query a large collection of documents. You can just ask a question and get a stream with all the responses that can take many time to be processed, but you don't have to do a sort of pagination or things like that you must do with REST. So out of the box, gRPC supports full TLS encryption. So this is great for security. So all the communication between all the services are encrypted using TLS. And the last point was code generation. So for the same reason that if you get like 3 or 4 endpoints in your API, this is not a huge problem because you can just write the code once and you don't have to be, it's not a problem. But at Scaleway, the number of endpoints we have, the fact that all the team are working on different API at the same time, the fact that they use different technologies, some may code in Python, some may code in Go, other in Rust. So we really want to be able, all the services to communicate with each other, no matter what language you are coding on. So gRPC come with code generation support that allow you to generate client code and server code in all the languages you want. So out of the box, you've got like, I don't know how many languages, but a lot. And which is also great. You can write your own code generation tool, your own plugin for the code generator. And we use that at Scaleway, for example, to be able to generate our Go SDK on GitHub. So we're making sure that the SDK is always up to date with the new REST version of our API. And also, we are actually using it to generate our new CLI, so the command line interface, to generate all our commands inside the CLI. So here, what it looks like, this is a proto file. So this is a file where we are describing an API. So you see it starts with a package name. So in our case, this is the scaleway.rdb.v1 package name. We've got a service name, which is called API, and RPC method, which is create database. The create database method is going to take a create database request as a parameter and will return a database object. We can also add annotation. So in this case, we have 2 lines of annotation and this will allow us later to do a binding between a REST API that we see when we do the curl and a gRPC backend API. So here we are just specifying that the create database request is post on the paths rdb1 region /database, and that the content of the request is going to be embedded inside the body. So the create database request is just a message, and you see that each parameter are strongly typed. So here we are working with string, but it can be bool, it can be enum. You have a lot of many different types, and the response will be a database with an ID and a name. So, and from this file, you can generate both the clients in many languages and the server side code where users have to implement the different method of your API. So our requests after the rate limiter is going to go through a service that is called gRPC gateway. And the mission of this service is going to transform the REST request to a gRPC one. So gRPC gateway is an open source software that we use at Scaleway, and that can generate, using your protobuf, microservices that will do the transformation of the REST request to a gRPC one. So if we go of how what it does, so when the request enters, it's the REST request we send with curl. So it's using HTTP1. It's a post on /database. We've got our token, the content type application JSON on our body. And after the transformation, so this is HTTP2, so the notation is a little bit different. And the way gRPC works is that all requests are always HTTP posts, and they are posting on / the full package name of the service. So in our case, it's Scaleway rdb_v1 API / the name of the RPC method. So in our case, create database. The content type is no longer application JSON, but application gRPC. And we see that the body of the request is no longer a JSON message, but a binary protobuf encode version of this message. So the JSON message is translated automatically by gRPC gateway to the equivalent version of protobuf. We still have our XOT token for authentication. And the X region that was before in the URL is now HTTP2 header. So the X region header. So then bring us to chapter 5, across the seas. So our request was to create a database in Amsterdam. So we must contact the database service that is present in Amsterdam. But because I am in Paris, the request arrived in the data center in Paris. So we are going to send the request from one data center to another using a secure HTTPS tunnel that we have between the 2 data centers. And this way, the request will arrive and will be received on the other end of the tunnel by another envoy in Amsterdam that will receive this request. So to do that, we use the X region header that gRPC gateway had before. And based on this header, we can configure Envoy to say, oh, I am in Paris. This request have X region header, so I must send this request to the correct region. So the Envoy will forward the request to another Envoy. Chapter 6, paper please. So after going through the border and arriving in a new data center, the new adventure is authentication. So authentication is the part where we are going to check the XO token of the request, make sure it's a valid token, make sure the token hasn't been expired or revoked, and check the permission associated to this token. So the way it works with Envoy, it's pretty similar to rate limiter. So Envoy will send the information of the request. So in our case, what's important for us is the XO token to an authentication microservices written in gRPC, written in Go. This authentication microservices will use the XO token and will call the user account, the Scaleway user account API that store all the user and their associated permission, and will make sure that the token is valid and will fetch the associated permission to this token. So the permission we will fetch at this time will be embedded inside the request that we send to our backend service. So when the service will receive the request, it will automatically receive the associated permission for the context of the request. So chapter 7, all roads lead to an API. So like I said before, we have many different services in Scaleway. Today we have more than 80 different services in production in 2 regions. We are planning to open a 3rd region before the end of the year in Varsovie. So this will add a lot more services because they are all duplicated in each of the region. So routing to the correct region could be difficult. Hopefully with gRPC, and because the URL of the request always include the service name, this task become much more easier. So here we just have to look at the path, and we automatically see that we are trying to contact the version 1 of the RDB API. So this way it's really easy to know which service this request should be sent to. So we probably have a configuration with a list of backend API that can receive this request. So in our case, for example, here we have 3 different backend server. And what we do is a simple round-robin load balancing. There are many different ways of doing load balancing in Envoy. I don't know how many type of configuration you can make, but many. For our use case, the round-robin was more than enough and was okay for us. So that's what we use. It would just go through each of the API server one after the other and do a loop for each request that comes in. What we took a lot of time configuring was health checking. So health checking, you have many different ways of doing health checking. So in Envoy, we use 3 different tools that Envoy provide. The first one is active health checking. So active health checking consists of sending, so Envoy will send a specific request to each of the server API and expect a certain response to consider the server healthy. So we'll say, hey, are you healthy? And the server has like a certain amount of time to respond, yes, I am healthy. If one of the server does not respond or respond, I'm not healthy, we just remove the server from the pool of backend cluster, and we can send the traffic to the healthy host. The second tool we use for health checking is outlier detection. So this is a feature of Envoy that allows you to configure the fact that if a backend server returns more than a certain amount of 500 HTTP error, for example, you can consider a service to be unhealthy. So in our case, we have a setting that can be a little different depending on the service, but the most common one is if we have more than 30% of 500 error in the last minute, we consider the backend server to be not healthy, and we will send the request to the other servers. So this automatically detects backend servers that can have some production issues. And the last one is a feature I discovered using Envoy, is the panic mode. And what panic mode is that it allows you to configure a threshold under which if you have less than a certain percentage of your backend servers that are healthy, Envoy will just ignore the health check status and will send the request to any backend server anyway, whether they are healthy or not. And we use it for two reasons. First, is that if for any reason we have like less than 30% of our backend server that are healthy, if we start sending 100% of our production traffic to these few backend server, they are probably going to be crushed under the load and they will become unhealthy themselves. So we don't want to do that. So if we go below a certain level percentage of failed health check, we distribute the request across all the different servers. And yes, some may fail because some may be sent to a server that is not healthy, but some will succeed. And at least doing that, we still are able to serve 30% of the request and not killing the few healthy hosts we have with all the load, leading us to 0% success rate. Another way where panic mode is important, and this joined the rate limiter before, so many services at Scaleway are new and were in beta or are still in beta now. So it's happened that sometimes that a service is deployed with buggy health check code. So the service is healthy, but the health check endpoint does not work correctly. So we may consider the backend like unhealthy, but in fact, it's perfectly healthy. So, and if we don't have the panic mode at this time, we will consider all our hosts like unhealthy, but in fact, they are healthy. So none of the requests will be sent, so we have 0% success rate. But with the panic mode, we will send the request anyway, and because the host is healthy, everything went fine, and the client didn't see anything. So now we reach our database API. Great. So our database can be created by the database API. So if we took at the time this took for this request to be handled, so the total request time is around 240 milliseconds. The rate limiter is really fast using the Redis cluster. It's really, really fast. So it's about 1 millisecond. The cross-region link, you can change physics. So you can go under the 12. Maybe you can reach 10 milliseconds to go from Paris to Amsterdam. Next, we get the authentication. It is about 30 milliseconds because it uses a SQL database for checking permission on the backend. So it can be a little more longer. And I'm going to finish with some metrics. So today we use it for more than 80 different services. Since I started this talk, I think we handle about more than 18,000 different HTTP requests. We collect more than 2,500 different metrics. And if you sum up all our Envoy instances in all our data center, in total, we are about 150 megabytes total of RAM usage, which is crazy small for what it does. So thank you. That's the end of my presentation. And we are going to have a session of Q&A. So feel free to ask any question about any of the thing I just presented, whether it's Scaleway related on how to do it, or even on the different technology I talked about. I will be happy to answer all your questions. Thank you.
Thank you, Jérôme. Thank you. You're the star of the show. Thank you for your perfect presentation. Yeah, if you could, well, I think you're doing it. Exactly. Stop sharing your screen. That way we'll get on to the questions.
It's done.
Thank you. So I'll go through the questions according to upvote. And of course, as we go along, feel free to ask them in live as well and react in the chat. Also, for those of you who don't have time to stay for the Q&A session or have somewhere else to be, there is a poll for us, for Scaleway, for the events team and the tech teams to ask for your advice. So someone from our team will put it into the chat, and if you could take a couple of minutes to reply, that would be amazing. So thank you very much. question time. So, Jérôme, first question for you. Are there some negative aspects, I suppose, negative points about gRPC?
Okay, so the answer with like all technologies is always yes. You cannot say no to a question like that. So it really depends on how you use it. In I think the most difficult point about gRPC is trying to present it and make and explain how this works to everyone in the company. REST is like today a de facto standard, so everyone is familiar with it. So going from REST to something else can be quite tricky there. Another point is tooling. Even if you have a lot of tooling in gRPC, this is not anything compared to what you've got with REST. For example, tools like Postman or curl, just a simple curl that allow you to quickly test your API. This does not exist with gRPC. You've got other tools, but they are not yet as advanced, I would say. So you probably, out of the box, you don't have as many tooling as you do with REST, but you still have some toolings. If you have time, you can build tooling that fits exactly what you need. But yeah, this I think for me, this is one of the biggest drawbacks. So there are good alternatives. For example, there is a software called Bloom RPC that we use internally. That is a GUI that allows you to just drag and drop your proto file into the interface, and you can start making gRPC code directly to the API. So it's even better than Postman because you don't have to write the different URL you want and the different payload, because the software will automatically detect that from the proto file. So this is one of the advantages of using gRPC.
Okay. Thank you. I think that was clear. Alexander, if you've got a question on top of that, please don't hesitate in the chat or in the question time. Next question is, does the rate limiter send back pressure info to Envoy to avoid it being swamped?
Okay, so today, no, we don't. There are many reasons for that. The first one is on front of Envoy, we have also a network anti-DDoS, anti-denial of service that is handled by the network team. So some of the work, if there are really bad attacks, are done using the anti-DDoS system. And for HTTP requests, we didn't have yet any problem with that. And this is why the first step of the HTTP request handling is the rate limiter. We don't want to do any work. For example, we do the rate limiter before converting it to gRPC, because this can be a little more costly than just the rate limiter. So yeah, this is really the first thing we do when the request arrives. And hopefully the Redis cluster we have will handle the load real fine.
Okay, thank you. Next one, I want to get it right, by Greg. Which software to run the DC to DC tunnel?
So actually this is Envoy. We use TLS point-to-point encryption between the two envoys. So in Scaleway, we have an internal CA that allows us to generate self-signed certificates that we use to secure our connection between all our components. And so we have one that is dedicated to securing the connection between two different regions. Okay. So it just, for the Envoy in Paris, the Envoy in Amsterdam is just like any other backend server. It doesn't even know it's an Envoy, it's just someone you can send requests to.
Thank you, I think that was very clear. Another question, Alexander, how do you organize yourself in terms of management with so many different teams?
Okay, this is a tricky one. So the first and most important success for that was a protobuf monorepo. So at Scaleway, we have a single Git repository that contain the protobuf of all the protobuf of Scaleway. So, and you have a central repo for that. And this helps a lot. First, because this allows us to have a dedicated team to review all the protobuf modification. So this way we can ensure that the different API exposed by the different products stay coherent with one another. We can make sure that the pagination system they use, or make sure the filtering mechanism they use are even for all the different APIs. So this is one of the really most important parts, was this big monorepo with a central validation system about what an API look like. And what this allows us to do next is, from this protobuf repo, we can, using CI/CD, automate a lot of generation, and we use the code generation. So when you push to the protobuf repository in Scaleway, this will automatically trigger the refresh of a Go internal Go library, a Python library. This will trigger the refresh of the Go SDK and automatically open a pair on GitHub. Same with the CLI. This will automatically update the command. If one argument was added, then in the CLI you will have one argument that pop in the merge request. So the response to that is really automation where you can. With many teams, you want to automate as many things as possible, and this is what gRPC is really good at, because of the strongly typed system and because of the way it's really easy to write custom generator, or the number of open source generators that already exist.
Okay, thank you, Jérôme. Next one by Roman. How do you make sure that two requests running at the same time and do change on the same resource don't interfere with each other?
Okay, so this we don't manage at the API gateway level. We didn't want to include any kind of business knowledge of what is going to happen inside a request. That's why we don't, for example, do a permission check. We just fetch the permission, send them to the backend server, and let the real server, the product server, to decide whether the request should succeed or be denied because of the permission. In the same way we do that with permission, we don't want to go inside the request and understand, oh, this is a create, this is a delete. So this will be handled by the product API. And the way they are doing it is probably using many of our APIs are backed up with PG SQL Server. So it's probably going to be a SQL transaction that avoid concurrent requests on the same resource.
Okay, I hope that answers your question, Roman. And if you've got more, please, again, feel free. We'll develop if needed. Next one, Gael. Is it possible to send the gRPC requests directly to the API?
So yes, you can. At Scaleway, we don't expose that publicly yet, but this is definitely something we want to at some point. This is a part where the big monorepo is a problem for us. It's because we have this big repo with both private and public API, and we didn't find the right solution yet to be able to separate them and be able to publish on GitHub the proto file we are using only for a public API without dependencies. And we really don't want to have two repos, because if we do that, we will lose all the advantages of this monorepo. So we didn't find the right solution yet, but this is definitely something we want to do. And in fact, today you don't have the proto, so you can't do it. But it's possible to send the gRPC to some public endpoint, and some of our products use that if they are hosted outside the infrastructure network of Scaleway.
Okay. Before I answer another question in the question tab, there's a question in the chat from Alex, and we're not sure what you mean. So if you could just develop a bit more, nice mug. If you could just develop a little bit more your question, and we'll do our best to answer it. But I don't think Melody understood fully what your question was. But please develop it a little bit more and we'll do our best. Next question. So that one is done. And what SSO software are you using / do you recommend?
So if by SSO you mean single sign-on, for the API gateway at Scaleway, we used the Scaleway user management. So this is not IAM, but if you're familiar with some other cloud provider, you can more or less consider like IAM. And this is really deeply linked with the way Scaleway is handling both permission and authentication. So when you are opening a Scaleway account, you will have an organization where your resources are attached to and billed to this organization, and you have a different set of permission that is attached to this resource. So yes, for that, this is a homemade solution. I don't have any recommendation for SSO standard. I mean, ready to use SSO. Yeah, sorry, never use one like out of the shell before, but yeah.
Okay. Now a new question from Alexander. What do you do when there's a bug?
Okay. So first thing is that Envoy, when a request reach Envoy, no matter where it comes from, the first thing Envoy do will assign this request a unique request ID. So this request ID will be passed along to all the microservices that go through till the end. So if we have this request ID, so if we have a bug, we can just get the request ID from the response. So let's say our curl in our presentation did not work. We have a 500 error, for example. There will be the X request ID header that we can get. And next, all our log from all the different services are stored in a central Elasticsearch cluster. And we can use this ID to find all the microservices it goes through and find and pinpoint at which points of the path of the request something went wrong. This helps a lot because with the number of microservices and with the fact that a request can come from one region to another, without that, it would be a pain to debug. But this request ID, this is how we handle it. In the future, we maybe plan to implement a tracing mechanism. So there is open source solution for that. One of them is I think it's called Jaeger. It's part of the CNCF2. And what tracing allows you to do is for each service the request is going to pass through, each service is going to send a ping or small messages to this open tracing software. And the open tracing software will give you a web interface where you can see all the different services it goes through all the time with a timeline of all the services, when it started, when it stopped. But we had some difficulties with that at Scaleway due to the number of requests we are handling. So if we enable this feature for all the requests that come to Scaleway, this would generate an enormous number of information. So we could use, Envoy, for example, enable you to enable this for a small percentage of requests. But if you do that, you can not use that for debug, because if you have a request that failed, that was not traced, then you can find it. So yeah, for us, logs is the way to go for now. And after that, we get many other tools like Sentry. So if a microservices spot an error, it will send a Sentry automatically. So that will send us notification on Slack, SMS, email, or whatever.
Okay, thank you. Another question from Gael. What is the main programming language at Scaleway?
So if we go back to the presentation Emma did before, so at the beginning on the online part, so the historical part of the company, which is like maybe 20 years old now, it's mainly written in PHP. So we still have a lot of PHP for the dedicated server product. When Scaleway start to create the instance product and the cloud elements product, they switch to Python. So many of the first Scaleway API were written in Python. And the newest one are mostly written in Go. And since I think 3 weeks ago, a team decided to start writing an API in Rust. So yeah, but Rust is really new. Go is like the way to go now for all the APIs that are going to being developed right now. Python for some of the older API, and PHP for the really heavy old one. And that's one of the benefits of gRPC, is that it allows us to really let each team go with the language that better fit the need, without having to rewrite all the library, because we can just use a generator for Potosi and generate the code for Rust, or generate the code for any other language you want.
Okay, very complete answer. Thank you. We've answered all the questions, Jérôme. I think we're
great.
If you have anything else to add, Jérôme, please do. If anyone's got a last-minute question, we're still here. Jérôme is amazing. Yes, he is. We all love his mustache. It's back. So thank you, Jérôme. Thank you, everyone, for being connected. There's a survey that Melody just posted. If you could please take 1 minute, it's not even a minute, to answer a couple of our questions. It'll help us. We'd like to know what future webinar you want to hear, what subjects you want to hear us talk about, if this one was good enough, and how to improve it if not. So if you have a moment, we'd really appreciate that. Again, you will be able to find this content on YouTube in a few days. We'll let you know by email anyway when it's online. Thank you, everyone, for being here one last time.
I just would like to add something. If you find what I present really awesome, I am looking for a tech architect in my team. So if anyone is interested, we will post the link in the conversation.
Yes, exactly. Please come join our team. Scaleway is the place to be, the place to work. So you can join Jérôme's team. It's one of the best teams. And lastly, this talk will be repeated, but in French this time, for the French-speaking ones out there, on the, is it 5th of May, Jérôme?
I think it is, yeah.
I think it is. We confirmed that today, and I think it's the 5th of May. Melody in the chat will correct me if that is wrong. I'm checking now.
Yes.
Yes? Yes, 5th of May. Good. Okay, thank you. So 5th of May at 5 p.m. So it's on our company page in Livestorm, as well as all the other webinars that we're organizing in the upcoming weeks. So keep an eye out on that. And thank you again. Thank you very much.
Thank you, everyone.